Hi, and welcome to day 9, and this is the power of algebra and finding Pythagorean triples. So Sam and Jill decide to explore a city. Both begin their walk from the same starting point. Sam walks 1 block north, 1 block east, 3 blocks north, and 3 blocks west. Jill walks 4 blocks south, 1 block west, 1 block north, and 4 blocks east. If all the city blocks are the same length, who is the farthest distance from the starting point? So, oh, that's not going to work for me here. Let me move this down. This is my starting point. Sam walks 1 block north, 1 block east, and then 3 blocks north and 3 blocks west. And this is Sam. Jill is going to start from the same point, and she's going to walk 4 blocks south, 1 block west, 1 block north, and then 4 blocks east. So, who is farther from the starting point? I'm going to make 2 triangles. Okay? And then I'm going to kind of extend this up here. And actually my little right angle needs to go in here. I need to find my distance from here to the top of the triangle. And since he walked 1 block north and then another 3 blocks north, this total distance for Sam is 4. And Jill is hanging out down here. And then he walked 3 blocks to the north, 3 blocks west. But the problem is from the starting point, he only walked 2 blocks. So I need to figure out how far Sam walked. And then Jill walked 4 blocks south, 1 block west, 1 block north, and 4 blocks east. So the distance from here to here is 3, because this was 1, 1, and 1. And then this would make this 3 as well for the same reason. And we're trying to find out that distance y. So I have 2 right triangles, so I'm going to use the Pythagorean theorem. So I have 4 squared plus 2 squared equals x squared. So I have 16 plus 4 equals x squared. So I have 20 equals x squared. Take the square root. So x equals, it would be plus or minus 20, but the problem is I don't need the negative because this can't be negative because it's an actual distance. So it's the square root of 20, which if we were to simplify would be 2 radical 5. And then I'm going to do Jill's. Jill was 3 and 3. So it's 3 squared plus 3 squared equals y squared. So 9 plus 9 equals y squared. So 18 equals y squared. Take the square root. I don't need the plus or minus because it's a distance, so it'd be 18. And that simplified is 3 radical 2. So who's farther? Well, Sam is farther. Because he's radical 20 units from his starting point, and Jill is only radical 18 points. So in this case, it's best not to simplify your answers because 2 radical 5 and 3 radical 2 really don't mean anything to me, whereas radical 20 and radical 18 do. So Sam is farther. or is farther. Prove that if x is greater than 1, then a triangle with the side lengths of x squared minus 1, 2x, and x squared plus 1 is a right triangle. Well, let's draw a picture. It's a beautiful wavy side of a triangle. Now, my hypotenuse has to be my longest side, so how do I know which one of these three is longer? There you go. Now, I know that x squared plus 1 has to be longer than x squared minus 1, because if I'm squaring the same number and then I'm adding 1, it's going to be more than if I'm subtracting 1. And if I take a number and I just double it, which is what 2x is, it's probably not going to be longer than my x squared plus 1. So to label, one side can be 2x, this side would be x squared minus 1, and my hypotenuse has to be x squared plus 1. And when we have a right triangle, we use the Pythagorean theorem. So I have x squared minus 1, the quantity squared, plus 2x, the quantity squared, equals x squared plus 1, the quantity squared. Now, we have a couple different options here, and I'm going to show you two ways to do this problem. We can use the principles that we've been using with the difference of like two perfect squares or conjugates and that kind of stuff. What I want to do is move this 2x over to the other side, and then this x squared plus 1. I want them pretty much to switch sides. So that means I have to subtract the 2x squared, and I have to subtract the x squared plus 1 squared. So I will have x squared minus 1, the quantity squared, minus x squared plus 1, the quantity squared, equals a negative 2x squared. And I'm going to treat this parentheses as A and this parentheses as B, because both of the terms are squared. And if I have A squared minus B squared, I can factor it to A plus B, A minus B. So I'm going to use that same concept over here. And when I do that, I'm going to have x squared minus 1 as A. And, okay, no thank you. What is it doing? Stop. Sorry. X squared minus 1. And then this will be plus, and this will be minus. And that will be x squared plus 1. And this will be x squared plus 1. And this is B, and this is B. So I have the same concept as I have over here. I'm just applying it a little differently. And that's equal to still negative and then 2x squared. Now, I now have conjugates, and when I have conjugates, I do not need to, let's see, what do I do? Hang on one second. Sorry, scratch that, I was getting ahead of myself here. What I'm going to do is take care of the math inside my parentheses, my brackets. So this is x squared minus 1 plus x squared plus 1. And this is x squared minus 1. And then I need to distribute that negative, so I'll have negative x squared minus 1. And this side simplifies to negative 4x squared. So square the 2, square the x. So here, when I combine my like terms, the 1's go away, and I have 2x squared. Here, when I combine like terms, the x squareds go away, so I have negative 2. When I multiply those together, I get a negative 4x squared, which is equal to a negative 4x squared. And this approach is the new approach, and it's probably not the easiest approach. So, see if I can get to extend my page here. Oops. Hang on. Alright, so I'm gonna also, oops, whoa. No, I'm not sure why I did that. But I'm also going to do the same problem with a second approach. And I'm going to work with this equation up here. And I'm just going to bring it down as if this was the next step. So x squared minus 1, the quantity squared is really x squared minus 1 times x squared minus 1. And then plus, we had 2x squared. So it's really 2x times 2x. And then x squared plus 1, the quantity squared is x squared plus 1 times x squared plus 1. Now I'm going to take and actually multiply those out. And I will get x to the 4th minus x squared, another minus x squared, and a plus 1, plus a 4x squared equals, when I multiply that out, x squared plus x plus the x to the 4th, because that's x squared plus x squared plus 1. I'm just using the distributive method, double distribution here, instead of the box method. Now, when I combine like terms, I will have x to the 4th, and negative x squared, and a positive 4x squared would be a plus 2x squared plus 1 equals, when I combine like terms over here, I have x to the 4th, x squared and x squared is made plus 2x squared, plus 1. Now one side matches the other, and it works. So the first approach I took was probably your non-traditional approach, where this would have been your traditional approach to doing the math. All right, that's it.